Hello class 7 students. Welcome back to this science class, and today we are going to start chapter 13 of your science textbook, which is electric current and its effects. Chapter at a glance. Electric circuits, heating effects of electric current, effects of electric current, magnetic effects of electric current. Engage. Study the diagram and answer the questions that follows. If both the circuits have closed switch, which bulb will glow brighter and why? Draw arrows in each circuit to represent the direction of flow of electric current. In class 6th, we have learnt about electric current and its importance in our lives. Devices such as torches, fans, TV and washing machines at our homes work on electricity. They can work only when electric current flows through them. तो हमने क्लास 6 में सीखा था कि कैसे हमारे घर में यूज होने वाले डिफरेंट डिवाइसेस इलेक्ट्रिक करंट की वजह से वर्क करते हैं. वो अगर इलेक्ट्रिसिटी नहीं होगी तो वो वर्क नहीं करेंगे. There are three conditions that need to be fulfilled for electric current to flow: a source, an unbroken path and a metal wire. तो इलेक्ट्रिक करंट फ्लो हो उसके लिए तीन कंडीशंस होना जरूरी होता है. एक सोर्स जहां से इलेक्ट्रिसिटी आए, दूसरा एक अनब्रोकन पाथ और तीसरा एक मेटल वायर जिसके थ्रू इलेक्ट्रिसिटी जो है वो कंडक्ट करेगी. तो इस चैप्टर में हम उनके बारे में थोड़ा सा और जानेंगे. In this chapter we will learn a little more about electric circuits, how to represent them conveniently and the effects produced by the electric currents. Electric circuits. Electric circuits are necessary for electric current to flow from one place to another. An electric circuit is a closed path in which the electric current flows. तो जो इलेक्ट्रिक सर्किट होते हैं वो एक क्लोज्ड पाथ होते हैं जहां पर जिस पाथ पर इलेक्ट्रिक करंट फ्लो होता है. A circuit is usually made by linking electrical components together with pieces of wire. The components such as cells, bulbs, wires, switches, etc. are called elements of an electrical circuit. Each element of an electrical circuit can be described by its symbol. Using these symbols, the circuit diagram for the circuit can be drawn. The important points to remember while drawing a circuit diagram are: first, there should be a source, that is one or more electric cells. Second, the wire should not have any discontinuity. Closed circuit and open circuit. The circuit in which electric current flows from the positive terminal of a battery to the negative terminal through all the components in the circuit is called a closed circuit. Components of an electric circuit. There are many different components that make up an electric circuit. Table given below shows some of the commonly used electric components, their symbols and functions. Electrical component. Electric cell. Symbol. Function. Generates electric current of small magnitude. Number 2. Battery. Its symbol and function. Generates electric current of comparatively larger magnitude. Number 3. Electric bulb. Symbol. Function. Gives light when electricity passes through it. Fourth, connecting wire. Symbol. Electric current flows through a wire. Number 5. Switch off. Symbol. Switches off the electric current through the circuit. Number 6. Switch on. Its symbol and its function. Switches on the electric current through the circuit. Number 7. Voltmeter. Its symbol and its function. Used for measuring electric potential difference between 2 points in an electric circuit. Number 8. Ammeter. Its symbol and function. Used to measure the amount of electric current flowing through a circuit. For an electric circuit to be completed, every part of it must be made of conductors. If there is an insulator in the path of the circuit, it is said to be broken or incomplete or open. Effects of electric current. When the electric current flows through an electric circuit, various effects of electric current are seen depending on the components being used. The most common effects of electric current are: A. Heating effect, B. Magnetic effect and C. Chemical effect. Here we will study only the heating and magnetic effects of electric current. Heating effects of electric current. When electric current is passed through a conductor, it generates heat due to the resistance it offers to the current flow. This is known as heating effect of electric current. The amount of heat produced by flow of electric current through a wire depends upon the following factors. First, material of the wire, second, length of the wire, third, thickness of the wire, fourth, amount of current flow. The greater the resistance offered by the wire to the flow of current, the greater would be the heat generated. That is why copper wires which offer very little resistance do not get heated up. On the other hand, nichrome and tungsten offer high resistance to the flow of the electric current and get heated up quickly. Applications of heating effect of electric current. The heating effect of current has many practical applications. The electric bulb, toaster, electric iron, geyser, hot plate, room heater, electric kettle and immersion heater are based on this effect. A. Electric iron. The electric iron is used for ironing clothes. It has a long flat strip of nichrome wire that acts as heating element. The nichrome wire is wound on around a thin and flat sheet of mica and kept between two mica sheets. When electric current is passed, the nichrome wire gets heated to a high temperature due to its high melting point. B. Electric bulb. It consists of a coiled filament made of tungsten metal enclosed in a glass bulb containing an inert gas at low pressure. When electric current flows through the filament, it becomes white hot and gives out light. Tungsten has a very high melting point and does not melt even when getting white hot. Number C. Electric fuse. The fuse is a safety device used in an electrical circuit to prevent a large amount of current flowing through a circuit. It consists of an alloy of low melting point fitted into a carrier made of porcelain or glass. Fuse wire is made from a low melting point alloy when large current passes through the circuit. This fuse wire gets heated up and melts away. As a result, the circuit is broken and further damage to the electrical appliances is prevented. In this image, you can see different types of fuse. Remember, A. A fuse is placed in the live wire. B. A fuses of proper rating should be used. Nowadays, fuses are available in different shapes. Magnetic effects of electric current. Like heating effects, current also produces magnetic effects. A Danish scientist, Hans Christian Ørsted, in 1819 discovered the magnetic effect of electric current. He was the first to discover that a wire carrying electric current possesses magnetic field around it. Electromagnet. A coil wound around an iron core that acts as a magnet as long as an electric current flows through the coil is known as electromagnet. In this picture, you can see an electromagnet. Uses of electromagnets. It is used to make electric motors that are used in several appliances such as fans, refrigerators, air conditioners, electric bells, and telephones. Second, it is used to separate iron and steel from other materials in a metal scrap yard. It is used in magnetic cranes for lifting and carrying heavy steel and cast iron articles in factories. Fourth, electromagnets are used on cranes in steel works and scrap yards for lifting heavy loads. In hospitals dealing with eye injuries, electromagnets are used for removing iron splinters from the eyes. Bullet trains use the principle of electromagnetism. The most important use of electromagnets is in electric motors. Electric bell. An electric bell is the direct application of electromagnets. It consists of the following parts, which are fitted on a flat wooden or plastic board. The electric bell makes use of the principle of an electromagnet. A horse hoe type of electromagnet is used in an electric bell. Following are the main parts of an electric bell. A. Horse hoe electromagnet. It is a U-shaped electromagnet consisting of a soft iron core with insulated copper wire wrapped around it. B. Armature. An armature is a soft iron bar. It is attached to the contact spring suspended from a pivot. C. Contact spring. It is a slightly bent metallic strip attached to the armature and hangs through the pivot. D. Contact screw. It is an adjustable brass screw passing through a brass holder. E. Switch. A push-button type electric switch is used to operate the electric cell. F. Battery. A battery is used to provide electric current. G. Hammer and gong. A hammer made of steel is attached to the armature. The gong made of metal is fixed on a wooden or plastic board. Working on an electrical bell. Step 1. When the switch is pressed, The circuit is complete and the current flows through the electromagnet. Step 2. The electromagnet attracts the armature towards itself. The hammer attached to it strikes the gong and produces a ringing sound. At the same time, the circuit at the point X gets broken, the current stops flowing and the electromagnet loses its magnetism. Step 3. The spring pulls the armature back such that contact is established again and the circuit gets completed. This keeps repeating with the hammer striking the gong repeatedly, thereby producing a ringing sound as long as switch gets pressed. This is the diagram of electric bell. Moral learnt. Electricity is the greatest invention in history because it opened people up to a whole new world. Without power, the world would never be able to innovate. Also, as time goes on, people continue to expand this invention and innovate it. Most inventions would have never happened without electricity. Recapitulation. The path along which the current flows is called an electric circuit. The current flows only if the circuit is complete or closed. If the circuit is broken or incomplete, the current does not flow. When an electric current passes through an electric conductor or a wire, the conductor/wire gets heated up. Electric irons, room heaters, electric ovens, water heaters, etc. use the heating effect of current to work. An electric fuse is a safety device. It prevents a large amount of current from flowing into any appliances or device. A current carrying wire has a magnetic field around it. An electromagnet is a coil wire wound around an iron core and it carries current. Thank you class. Let's meet again in the next chapter.